Okay, question 8. We've got our uniform rod, mass of 4 kilograms. So the first thing we know is that the centre of mass is at the centre of the rod. We know that the rod length is 1.4, which means that my weight, which would be 4g, would be 0.7 away from either end. The string is perpendicular to the rod, lies in the same vertical plane, equilibrium. Find the tension in the string. Okay, so the string, this is the string here, so T is what we're looking for. Now, forces acting on this, there's going to be forces at this point, for sure. And if you read on, it says find the coefficient of friction, which means I know that I'm going to need a normal reaction there and my frictional force here. Now, if I want to find T without getting this involved, what I need to do is take moments about A. So if I take moments about A, then I need to only be dealing with these two forces. Now, this force is already perpendicular to this rod, so it's all, we're always thinking about the rod as our point that we take things relative to. So T will just be times by 1.4 for my moments about A. Now, my 4g newtons, what I need to do is actually resolve that perpendicular to the rod. Now, if that's 20, this angle here will also be 20. We've obviously got another component here of it, but this would go straight through the point that we're taking moments about. So this component will have no effect. So the only one we need to look at is here, and that would be 4g cos of 20. So as I do my moments then for the 4g, it's going to be 4g cos of 20 multiplied by 0.7. So T is going to be 2g cos of 20, which works out as 18.4 newtons. So that will be part A. For part B, we're told that the rod is about to slip, so we need to be thinking in terms of limiting equilibrium, obviously. Now, if you look at your diagram, make sure your diagram's got clear forces on it. What we need to be doing is resolving. So when we do these moments questions, there's two things that we do. We resolve and we take moments. And the resolving is often easier than taking moments because we don't need to worry about the distances. So for part B, we're going to resolve. I'm going to resolve vertically. So the force is going upwards. I would have R plus. Now if I look here, I've got T. That's got an upward effect. But at the moment, T isn't upwards, vertically upwards. So I need to be thinking of that component resolved to there. Now if I put my angles in, this would be 20 here, and this would be 20. So this component here will be 20 cos of, T cos of 20, and this one would be T sine of 20. So vertically upwards then I've got R plus T cos of 20, and that will equal 4g. So I need to work out what R is. 4g minus T cos of 20, and that comes out as 21.9 newtons, or I can leave it as this if I want to. So then I need to resolve horizontally. Horizontally, only forces I've got going on here is mu r, no effect, no effect, and here I've got T sine 20, so I would have mu r is equal to T sine of 20. I know what T is, I know what R is, so I can work out what mu is. So it'll be T, which was my 2g cos of 20, sine of 20, divided by my R, which was 4g minus T cos of 20, and mu comes out as 0.287.